Welcome back. Let's solve LeetCode 1448 today. Count good nodes in binary tree. So what is a good node? Well, let me explain you. It's not that hard. Basically, a node would be good node. A node would be considered good node if all the nodes that were previous to it are not greater than it. For example, here we have 5. Okay, for this node we have 5. Now, is 5 a good node? Well, it depends. If all the node that came before it, if they are not greater than 5, then 5 would be a good node. Okay, so yes, 5 is a good node. Now let's see 1. Is this a good node? No, it's not a good node, because if we look at the path that it is in, we see that the node 3 is greater than 1, the node 4 is greater than 1, so 1 is not a good node. So let's just look at the whole tree, how many good node we get. First we have here, we are in the root node. Of course root node is going to be a good node because there's no node before it. So yeah, for 3 this is a good node. Then we go left, we got 1. Is there any value before it which is greater than it? Yes, we have 3 here and now we have 1. So 3 is greater than 1, so 1 is not going to be a good node. Then we go left once more. Now we have 3. Is 3 a good node? Yes, 3 is a good node because we had 3 before, but 3 is equal to this 3. It's not like the root is greater than this. If the root was greater, then this won't be a good node, but since it's equal, it's a good node. Then let's go left, let's go right. Here we have 4. Is this a good node? Yes, this is a good node because it's greater than 3. Then we go right once again. Is it a good node? Yes, this is a good node because this is greater than 4. And of course this is not a good node because in this path 4 is greater than 1 and 3 is greater than 1. So it depends on the path. You see, we have to go through each path separately and we have to see if there's any how many good nodes out there. So we see that in this tree we have 4 good nodes. That's why the output is 4, answer is 4. So now let's talk about how can we solve this question. Actually it's very simple. We just have to keep track of the maximum value that we got from the node, and that's how we can keep track. For example, when we are here, we are in the tree, so we keep track of the maximum value. So right now maximum value is 3 itself. Why? Because we just got to the root, so this is the maximum value. So from this we go left. Okay, now we have 1. So is 1 greater than the is 1 equal or greater than the maximum value? No, 1 is less than maximum value, so 1 is not a good node. So we go left once again. Now we have 3. Is 3 less than the current node that we have, the current maximum node that we have? No, it's not lesser than the current maximum we have. That's why 3 is a good node. Now we'll go to right. So now we have 4 and we see that 4 is greater than 3. So this is a good node, and we will also have to update our maximum value, because right now we have 4 which is greater than 3, so we'll just update our maximum value. So we have 4 now. Then we go here 5. We also see that 5 is greater than 4. So 5 is also a good node, but we also have to increase our maximum value that we get. So that's how we will just keep track of the maximum value, and if we keep track of the maximum value, we can just easily solve this question. So let's just go to the question. So of course we cannot do this inside of this specific function because they didn't give us that opportunity. We cannot take maximum value here, so we have to call another function. Let's say it's just going to return us the answer. So the answer, let's call it helper function, will give the root and the value of root. Now why are we giving the value of root? Because this for currently that is the biggest, like that is the largest number, right? Because we just went to the root, and then return answer. Okay, now let's just write the helper function. So we took as the input, we took the root and we took the maximum value. And then what do we have to do inside the function? Like I said, we have to check if the value of root is less than, okay, no, less than, okay, if the value of root is less than the maximum node, then we won't update. So we'll have to check if the value of root is greater than or equal to maximum value that we have. And if that's the case, then we'll just, okay, we have to take the answer integer here, and for now we'll just have to keep it as 0, and then we'll have to update it here, answer plus plus. Then of course we'll have to update the maximum value if we see that because the root node can have a larger value, right? So we'll have to check it with the maximum value. So that's done. Now what we have to do is we'll just have to add the left side and right side to the answer. So let's call the helper function again, root left plus maximum value, and then answer plus equals to helper root right. Okay, of course we'll have to take the maximum value as well, and then we'll just have to simply return the answer. However, of course we'll have to end the recursion, right? So to end the recursion, we'll have to, if no root, okay, no, not root, I don't know, let's just say it's null. That's going to work as well, but I just don't know why I wrote it like this. Okay, let's just do that. Okay, instead of writing all this, if not root, return 0. So I'm guessing it's gonna work. Let's just see. Yeah, it worked fine. So let me just submit it, or wait. Yeah, it worked fine, alhamdulillah. Okay, but okay, let me show you something else as well. Something that I like to do is that instead of returning integer, I just like to take a global variable. I do this because I think like taking answer from the helper function and then adding all that up in recursion, I kind of find it like irritating. I don't know why. So I'll try something else. So basically, like, I'll just take a global variable and change it that way. So I won't need this right now. Okay, in answer I'll have to give 0 over here, so I won't need this line, and here I don't need all of this. Okay, I don't also need to return anything because it's void right now. So let's see if it works now. Okay, we cannot say return 0 because it's returning void. Yeah, that way you can see that it worked as well. So let's submit this one as well. So that was the answer. I hope it helps you.